I swear, if they give you this on the FRQ, consider yourself lucky. This was question 6 on a 2016 FRQ AP Calculus AB exam, and it just involves tables of f, g, f prime, and g prime, and all we have to really do is find the derivatives and talk about some integrals. So let's go ahead and do this together. So for this particular question, it looks like they give you a table of values. We have the function of f of x, f prime of x, g of x, and g prime of x. So immediately I have a feeling that they're going to ask us stuff about, these functions. So they tell us that the functions f and g have continuous second derivatives. The table above gives a value of the functions, which we have already mentioned. And then so for part A, they say k of x is equal to f of g of x. So we have the composite function, and they want us to write the equation for the line tangent to the graph of k at x is equal to 3. So immediately I'm already thinking that they want us to find the line tangent. So I'm obviously going to use y minus y1 is equal to m times x minus x1. First, I'm just going to go ahead and find the slope, and that slope is going to be the derivative at the point x is equal to 3. So if we want to find our derivative, don't forget k of x is equal to f of g of x. So when we take the derivative, we need to apply the chain rule. This is the simple definition of a chain rule problem, f prime of g of x times the derivative of the function that we have inside, which is g prime of x. And then now we can go ahead and plug in the values for 3 in for the x. Let me just go ahead and write everything down. So first thing that we want to find is the g of 3. Looking at our table, we're going to focus on the g of x. And we have the 3, so now we know that g of 3 is going to equal to 6. So I'm just going to rewrite that. I have f prime of, I'm just going to write the 6. And you know what? At the same time, let's just go ahead and find the g prime of 3. So on our table, we have the g prime column, and at 3, it looks like our g prime of 3 is going to equal to 2. So I'm just going to go ahead and put a 2 out there. And then now the final step is to find the f prime of 6. So back to our table, f prime of 6 is here, or that's our f prime, and then now we want the 6, which is going to be, f prime of 6 is going to be equal to 5. And so now we have 5 times 2, so the answer is 10. Okay, that's our slope. If they were asking us for the slope of the tangent line, we are done. So now we can go ahead and say that our equation looks like this. Y minus y1 is equal to 10 times x minus x1. Okay, well, x1 is just the x value of this coordinate, and we already know that that's going to be 3, so we can go ahead and plug that in. We have 10 times x minus 3. We just need to find the y1, and that's the y coordinate that corresponds to the x value of 3. So we need to find, let's go ahead and put this on the right side. Check this out. We need to find k of 3. Okay, so that's going to be f of g of 3. So let's go ahead and look at our table. So first we need to find g of 3. So g column there at 3, that's going to equal to 6. So then we need to find f of 6. So this is our f function at 6. The value is 4. So now we know that k of 3 is going to equal to 4. So let's go back to the equation on the left-hand side. So now we have y minus 4 is equal to 10 times x minus 3. And I think you can just leave it like this. If you wanted to simplify it and leave and isolate the y variable, you're more than welcome to. But this is it. This is part A. We're done. Let's go to part B. So part B, they give us a different function. H of x is equal to g over f of x, and they want us to h prime, or they want us to find h prime of 1. This is interesting because all we need to do is take the derivative in terms of x, so we're going to use quotient rule. But what's interesting about this is that we're so used to having the f on the top, g on the bottom. So I have a feeling they're trying to confuse you, thinking that some people might have memorized this in terms of f and g's. So they might get this answer wrong. What I mean by that is that a lot of people are used to seeing the function like this. So when they take their derivative, it's just g of x times f prime of x minus f of x g prime of x over g of x squared. And they might think, okay, I'm just going to go ahead and write that down for my derivative. But this is incorrect because the f and the g are in different orders. So in order to find our derivative, we're actually, just using quotient rule, but the variables are a little different. So it's going to be f of x times g prime of x minus g of x f prime of x over f of x squared. I like to always remember this as low d high minus high d low over low low. It's everyone's choice on how they want to memorize it. But that's the derivative using quotient rule. And now all we have to do is find h prime of 1. So this is f of 1, g prime of 1, minus g of 1, f prime of 1, all over f of 1 squared. So looking at the table, that's what I'm going to do to find f of 1, g prime of 1, and all that stuff. So f of 1 looks like it's going to be -6 times g prime of 1. Looks like that's going to be 8 minus g of 1 on the table. That's 2 times f prime of 1, which is going to be 3. So we're using all the values over f of 1 squared. So that's going to be -6 squared. So we just have to simplify this. -48 minus 6 over 36, it looks like. So what? -54 over 36. And somehow I think we could divide that by 9. So -6 over 4. Oh, divided that by, looks like, oh, that was 18. But anyway, -3/2 will be our answer. Just continue to simplify it. I think they're going to want you to do that during the exam. Again, I still can't believe that this was an AP FRQ. By the way, this was the year 2016. All right, final question, part C. They want us to evaluate the integral from 1 to 3 of f double prime of 2x. Now, you might think this is a bit confusing because we have no idea what the function of f is going to be, but you know, that's why they're doing this, because they want you to kind of use some u substitution and use the idea that the integral is the antiderivative of a function. So first, let's go ahead. I want to have this just all in terms of x, or in terms of one variable. So I'm going to use u substitution. U is equal to 2x. That means that du is equal to 2 dx. There's a few ways that people do this, but I like to divide the 2 to the other side. So I get du over 2 is now equal to dx. So we're going to go to our integral, and now we're going to have integral of f double prime of 2x was now u, integral, and then our dx is now du over 2. And notice that I didn't put the parameters because we're going to talk about that now. Okay, so when the parameter was equal to 1, this is in terms of x, so we got to turn this back in terms of u, because now we're going to have an integral that's just in terms of u. So when x is equal to 1, we're going to refer to this equation because that's our relationship between u and x. So we're going to have u is equal to 2 times 1. That means that our u value should be 2. So I'll go ahead and plug that into our lower parameter for our integral. And then now we have the last one, which is 3. So back to our u is equal to 2x. U will equal to 2 times 3, which is equal to 6. And then I'll go ahead and put that as my parameter, 6 up there. So just to kind of, rewrite this integral here, the 2 is in the denominator, so we're going to pull that on the outside to make this 1/2 integral from 2 to 6 of f double prime of u du. And now this is perfect because it's just a simple integral with a function with one single variable. So we could think of this almost like an x, but again, it's still in u. So the antiderivative of f double prime of u is going to be f prime of u, going to be from 2 to 6. I can go ahead and plug the the value of 2x back in, but then I have to change my parameter, so why not just keep it this way? So according to the first fundamental theorem of calculus, this is now f prime of 6 minus f prime of 2. And let's go ahead and simplify this. F prime of 6, looking back at our table, f prime of 6 is going to be 5 minus f prime of 2 is going to be -2. So we just have to be very careful with our negatives. Ooh, well, I have space. Let me kind of move this up here. This will become 1/2, and then in parentheses, 5 plus 2. So this is going to be 7. So our answer is 7/2. There you have it. A simple AP Calc FRQ. Will they have this on the exam this year? I hope so, because that'll be really simple. If not, now you have an idea of something that could occur on the exam.